All right, how's everybody doing? Me, not so good, hence this video. So there'll be a sub, and maybe for 6th period and 8th period, and maybe Ms. Bullock will help you out. I'm going to create this video for Geometry Unit 1, Big Idea 2, Lesson 3, okay? So at the rolly cart down by the door, you will find the paper copies, or you can use your Chromebooks, of course, if you choose so. Everything's on Google Forms now, on the Google Classroom, so let's get started. Learning target today. Learning target today, actually, if you use the paper copy, I don't know what happened. Wrong learning target got the paper copy. But don't worry, since we always write our learning target on our lesson anyway, here's the real learning targets for today. We have I can classify angles, acute, obtuse, straight. So I can classify angles, acute, right, obtuse, straight, and just we can write one for today. We'll get to the others later. If you want to write this one, however, I can use the angle addition postulate. Maybe that one's a little shorter for you. Or I can determine the measure of an angle when given a bisector. All right, so you maybe want to pause the video right here just for a moment while everyone writes their name on their lesson and gets one of these learning targets down on their page, right here, right? So get your name on there, write down that learning target, unpause the video when you're ready to continue. Okay, pardon me. Sorry, that's going to happen a couple times. Still working on that. Okay, little vocabulary review. Okay, angle. When any two straight geometric figures intersect, they're going to form an angle. They can form all sorts of angles, right? Okay, so that's an angle. Any two straight geometric figures intersecting will form an angle. Where they form an angle, that little point right there is the vertex. Where they form that angle, that's the vertex of the angle. All right, vertex. Ray. Ray is a geometric figure that starts at a certain point and goes infinitely in another direction, right? It's like a laser beam. It starts here where the laser gun is, and then it shoots infinitely in one direction. So an array has infinite length, but it starts at a specific point, which is unlike a line, which is infinite in both directions, right? So lines have infinite length, rays have infinite length, and line segments are finite. So when you hear line segment, that's finite. It starts at one point, ends at another point, okay? So that's ray, that's line segment, that's line. Straight angle. So a straight angle is a straight line, right? A straight line is a straight angle. If there's any bend in it, it's not a straight angle anymore. So a straight angle is a straight line, which is 180 degrees. 180 degrees, okay? Don't worry, we go over vocab every day, so you'll remember that. Degree measure. We measure degrees using an old Babylonian method. We won't get into the history right now about why they did this, but a circle has 360 degrees, and that's how we measure degrees in this 360 degree format. So half of a circle would be 180, like a straight line through the circle, right? And then 1/4 of a circle would be 90 degrees, which we'll talk about as a right angle. So 1/2 of a circle is 180. A full circle is double that, 360 degrees. And then 1/4 of, I can't quite, 1/4 of a circle is going to be 90 degrees, all right? And 90 degrees is a right angle. Anytime two straight things intersect to form a right angle, they form a 90-degree angle, which is very similar to perpendicular here. Perpendicular means a right angle. When two things intersect perpendicularly, that means they intersect at a right angle. Okay? Throwing a lot at you right here. Wondering if I have any, okay. Pardon me. All right, what else? Oh, perpendicular bisector. Okay, big word, perpendicular. Remember, it means right angle, 90 degrees. Bisector. Bisector means it cuts something else in half. Keep in mind that the perpendicular bisector is the scissors. It's the thing doing the cutting. The bisector will cut something else directly in half. So the bisector is the scissors, and the thing it cuts in half is the thing being cut. Okay? So keep that in mind. Bisector is a thing that is doing the cutting. We're going to skip sector. Congruent. If two things are congruent, that means they're the same measure. I also remember same size, same shape. So congruent, same size, same shape, same measure. A point is just an infinitesimally small little dot. And when I say infinitesimally, that word means infinitely small. It has no dimensions whatsoever. It's just a point in geometry. We already went over leg. Length measure, okay. Acute. Acute. Any angle greater than 0 and less than 90 is acute. So anything like this, all the way up to like there, 89 degrees, is all acute angles, okay? So these are the acute angles. They can be on the other side too, from here to here, right? All acute. A right angle is always, well, we already talked about that, right angle, sorry. Right angle, always 90 degrees. Obtuse, as you might guess, obtuse is anything greater than 90. If you were in class last week, we went over these two. But we're in this. So for some of you, this might be a little bit review, but for some of you, this might be hearing it for the first time. Circle, remember? Circle, 360 degrees. An arc. If you think of a circle, like a pizza, the outer crust, like one slice's outer crust is going to be an arc, right? An arc is part of a circle. A radius. A radius, if you think of a circle as a pizza, the radius is the center out to the crust, right? Cutting from the center out to the crust is a radius. Oh, pardon me. I gotta clock in here. It's gonna ring 9 times because unfortunately the first time I made this video, the audio didn't record. Tragedy. So now I gotta do this again. You know, and it's gonna ring 9 times because it's 9 o'clock and I would like to go to bed. Okay. Maybe you wanna fast forward through this little piece. I don't want to talk over it. Okay. Almost. We're almost there. It's almost done. Okay, it's all done. All right. So we talked about line segment, circle, radius, equidistant. Equidistant means the same distance. So if two things are equidistant, that means they have the same distance from each other, right? So equidistant is equal distance, same distance. Bisect means to cut in half. If you've ever heard of a dissection, right? Dissection means to cut, and a bisection is to cut in two, right? To bisect. Midpoint. Midpoint is the point in the middle. So if you know of the midpoint, then you know that it's cut in the middle, which means the two halves are going to be the same length. They're going to be equidistant. Compass. A compass is our circle tool. We use the little safety compasses in our class often, but there's also the little twisty, old-fashioned compass as well. Construction in geometry. A construction is just when we have like paper and we're drawing a diagram using those very technical skills of compasses and straight edges and that kind of stuff. And protractor. Protractor is your angle measuring tool. It's your little half circle tool that has all the angles on it. That measures angles, and we'll be practicing that today. All right, that's the vocab. Moving on. All right, here's the warm-up. I like you guys to do these by yourselves, so if you don't mind, please give this a shot. Pause the video here, take a minute, do these next 4 questions, see if you can classify these angles, whether acute, obtuse, right, straight, or reflex. Haven't taught you about reflex today yet, so reflex isn't going to be one of your options. Go. All right, you gave it a shot, hopefully. All right, well, let's look at this one. We see right here we have what looks to be a nice 90-degree angle. So we're going to call this one perpendicular or right, right? This is going to be a right angle. Over here, classify this angle. Hopefully you're looking at that and you're saying, geez, that looks like a straight line. So it's a straight angle, right? Good. Classify this angle. Hopefully this didn't stump anybody, right? It's not a right angle. Nope, not a right angle. It's not acute. It's not less than 90. It's not straight. So obtuse. Greater than 90, less than 180. And classify this angle. Oh, ain't that a cute angle? Less than 90 degrees. There it is, a cute angle. All right. These are just notes. Just reminding you that congruent angles have the same measure. And we put these little marks on angles when we know they're the same measure in geometry. They're called arc marks, and the fact that there's one here and one here means that these two angles are the same measure, right? This is that little indication on your diagram that these two angles are the same measure. We did this construction in class recently. I will do that with you when I get back. This is a diagram of how to construct a congruent angle. I got some noise going on. All right, sorry about that. All right, so to copy an angle, or to create a congruent angle, to do this construction, to construct an angle congruent to angle A here, we're first going to create a straight line as the base, right? This will model this piece of angle A right here. And then we're going to take our compass tool. Now our compass tools look a little different than this, but the same idea. It's a circle tool. We're going to put the one end of the circle tool over here, and we want to make this arc mark here, right? We're going to make this arc mark. So because all the radii of a circle are the same distance, this here, this distance between A and this little part of the arc right here is going to be the same distance as between A and B. All right? Then we're going to transfer that same kind of arc over to our base over here. We're going to transfer that same kind of arc over here, just like we had on angle A. We're going to transfer it. And then what we're going to do is we use our circle tool as kind of like a ruler. We're going to take a measurement between where the arc is over here, right? We'll put our compass here and take a measurement from here to here and figure out what exact distance is that. And we're going to remember that distance or use it again on our construction, which will put our compass here and give that same distance over here, and where those two arcs meet, that will be a copied angle. And now this angle here, angle D, is congruent to angle A. Again, we did that one in class. I'll show it to you in person. Angle addition postulate. We've actually gone over this before in class. Remember, this one is the one where I say it's part plus part equals whole. So try to remember that. I apologize, the writing is sloppy today. I am using not as advanced technology as I usually use in the classroom. Part plus part equals whole. Oh, that's terrible. Apologize. That's what it is. All right. Part plus part equals whole. And what that means is that this part, this angle here, well, actually maybe I should do it like this angle here is the same measure as this angle. I'm sorry, this angle here plus this angle here is going to equal the whole angle, the whole thing, right? And I need to make two arc marks here because it's not the same size as these two. So part plus part equals whole. Does that make sense? So here in this example, they're saying to us that the measure of angle ABD. All right, let's find ABD. Always trace this out. ABD. They're saying this is 37. So put a little 37 right here on your paper copy, or draw a little diagram on a paper if you're doing this on a computer. And the measure of angle ABC is 84. Okay, so then this whole thing is going to be 84. And what we know is that part plus part will equal whole, right? So wait, if part plus part equals whole, this is an equation. This is an equation. We can set this up in terms of math, right? That this here will equal this piece plus this piece. And we know what this piece is. We know what that piece is. And we can give this a variable. We can call that x, which is really just a question mark. Don't know what x is yet. Since I don't know what it is, I'll call it x. I could call it z. I can call it r. Doesn't matter. So I'm going to say, well, 84, which is the measure of the whole, is going to equal 37 over here, plus x, plus whatever the measure of this thing is. Well, we're going to use those algebra skills, right? We're going to use those algebra skills, and we're going to subtract 37 from both sides. Why do we want to subtract 37 from both sides? Because we want to figure out what this is. So to figure out what it is by itself, we need to get it all by itself on one side of the equation. So we're subtracting 37, because 37 minus 37 cancels over here. It becomes 0, which means I can ignore it on this side of the equation. But then 84 minus 37 is 47, and hey, guess what? That means I know that this is 47. This angle right here, x, is 47. Simple enough? All right. Pause right here if you still need this. I'm clearing it, and we're moving on. See if you can give this a try. Pause the video if you need. Sorry. Sorry. All right. XO. if the measure of angle XWZ is equal to 121, so let me mark that in my diagram. They're telling me that the whole thing here is 121. I always advise you to mark up your diagrams like this. This will help you remember what the word problem is telling you. They told me that XWZ is 121 degrees. The measure of angle XWY, this guy right here, XWY is 59. 59 goes in right here. All right. So now then we're going to find the measure of angle YWZ. Again, we call this X. So pause the video here and see if you can try this. All right, you pause the video, you tried it yourself. Let's see. I'm not going to completely finish this, but I'm going to help you out, okay? So part plus part equals whole. Let me set this up for you. The whole is 121. So 121 will go here. So now I need part plus part. And I have one part is 59. There's 59. 59 plus whatever x is, plus x, will equal 121. So my next step is I want to, again, subtract the 59 so I can get the 59 over here, so I get x by itself. And that will tell me what x is. If I want to know x, I got to get x by itself. So minus 59 minus 59. Remember, this cancels. 59 minus 59, boop. It becomes something I can ignore. And an equation is like a balance beam. If you subtract 59 from one side of the equation, you have to subtract 59 from the other side. Well, I'm going to leave you right here. X is going to equal whatever 121 minus 59 is. And I'm not going to tell you because I want you to pick up some calculators and figure this out. Moving on. Okay, an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. All right? So what we're told here is that JK, actually I read this ray JK, bisects, cuts in half, angle LJM, angle LJM. Thus, therefore, thus means here, angle LJK is congruent to angle KJM. So if that doesn't make sense to you, if JK is cutting this big angle in half, if you cut something directly in half, then each side is equal, right? If you and I work together and we do a job and the job paid out $500 and we split it evenly, if we cut it in half between us, we each get $250, right? So if something gets cut in half, each half is the same. Here's how to construct an angle bisector. Again, we did this construction in class. If you need to go over it, we'll do it in person together. But essentially, you're going to use your circle tool to create this little arc. Again, making this distance equal to this distance. AB here is going to be the same distance as AC because they're both the radius. They're both radii, plural, of a circle. And then once we get this little mark written or drawn in, constructed, we will then put our circle tool here on B, where the arc goes through this this side of the angle, and then we'll do another little circle right here, and that creates this little arc mark. And then move the compass over here on C and do the exact same size circle on over here, and where the two arc marks cross, that is going to be where this angle is divided in half. Sorry. All right, sorry about that. Little announcements in my house. All right. Note. So this is just finding the measure of an angle, right? Using the algebra stuff. We all love this algebra, right? So here's the situation. This is like a pretty typical kind of situation they might give you. Ray BD. This little arrow here means it's a ray. Ray BD. There's ray BD. Okay, it starts here, goes infinitely in this direction. Bisects, cuts in half, angle ABC. There's ABC. So this big angle here is getting cut in half by ray BD. And then they tell us that the measure of angle ABD equals 6x plus 3. Now, I can't possibly write that in there, but I'm just going to say ABD. So this right here goes in there, right? That's the measure of that angle right there, ABD, and the measure of angle DBC. That's how you read this. M means measure. This little symbol here is the angle symbol, the measure of angle DBC. DBC is going to be 8x minus 7. So that goes in here. So using this part, actually this is using the bisector. So they want us to find the measure of ABD. So we want to find, what we want to find is this right here, question mark. What is that? Well, we got a little hint when they said bisects, right? What we know about bisectors is they cut things in half. And we know that when things get cut in half, both halves are equal. Well, that's an equation. That's an equation right there. Both halves are equal, which means if I know this is 6x plus 3, and I know this is 8x minus 7, then I know that the two things are going to be equal to each other, right? Because they're both halves that just got cut from a whole. They're both equal halves. So I'm going to set this up in an equation. I got 6 times a number I don't know plus 3 is going to equal 8 times that same number I don't know minus 7. Apologize again for the clock. It dings every 15 minutes. All right, so just a little strategizing here. I kind of want to move the 6x eventually over here to the 8x, which leaves me with a positive x figure. So my strategy is to move the 7 first on over. So since I want to move the 6 over here, I'm going to move the 7 first. So I see that I have a negative 7 here. How do I get rid of a minus 7 or a negative 7? Well, I'm going to add 7 because a negative 7 plus positive 7 just becomes 0. So this cancels. Then if I do, again, equations are balance beams. If you do it on this side of the equation, you got to do it on the other side. So I got to add 7 on this side too. 3 plus 7 is 10. So now it's a little bit simpler. I got 6x, 6 times a number I don't know, plus 10 equals 8 times a number I don't know. Now this is where I'm going to move the 6, right? I'm going to move the 6x over. So I don't know what this number is yet. I don't know what 6 times this number is, but I can subtract 6 times that number from 8 times that number, right? So I can, if I do it over here, subtract the positive plus the negative, cancel each other out. That cancels. 8x minus 6x is going to be 2x because 8 minus 6 is x. So what am I left with? The 10 goes back down. I'm left with 10 equals 2 times a number I don't know. So 2 times x. Well, I can go from there. I can start dividing by 2 on both sides, right? Because this is 2 times a number I don't know. Well, if I divide by 2, multiplying by 2 gets canceled by dividing by 2. It undoes it, which just kind of cancels these 2's out, and I get x is equal to 10 divided by 2, which is 5. All right? Getting rid of all that. We're scrolling down. So x is 5. And then to figure out what this angle here is, which we wanted to know, question mark, we then plug 5 in for 6x plus 3. Remember, this one here is 6x plus 3. So plug 5 in. 6x plus 3 is the angle measure. We know that x is 5, so 6 times 5, well, that's 30. 6 times 5 is 30. Plus 3 is 33. So we found out that this one here is 33. All right? I know that's a lot of steps. I know that can be intimidating, but you can do this. This is just, it does take a number of steps. I would say probably pause the video right here and then try this one, this example right here, okay? Pause the video, give this a shot, 2 minutes, don't get frustrated, see what you can do. Before you get started, hopefully you didn't pause it already, before you get started, let me help you with a diagram, because you always want to diagram this. I mean, this is, until I diagram this is gobbledygook to me too, right? I can't look at this and visualize it, I need to diagram it. So, let me see here, the first thing I got to worry about is this ray QS bisects angle PQR. Okay, so I have ray QS. So here's my ray. It goes infinitely in this direction. And then over here is Q. And then over here is S. All right, there's my ray QS. Starts at Q, goes on infinitely. Now I got to somehow figure out how does this relate to PQR. Ray QS bisects angle PQR. Well, notice that Q is the same in both of these angles, or from the ray and the angle has the same. So that means that this PQR thing has got to be something that looks like this, where I get, oops, sorry, and trying to make this look pretty good. All right, where this has got to be P, and that's Q, which means that's got to be R. And you want to always diagram these, right? This way you can visualize it, see it. All right, so let's think about what we got here. We got ray QS, there it is, ray QS. Bisects, cuts in half, angle PQR. Well, what do I know immediately about when something bisects an angle? It means it cuts it in half, which means both halves are equal. So I'm going to put these little arc marks in here. These little arc marks tell me that this is equal to that. I don't know what they are yet, but I know that this one is equal to that one. Okay, fair enough. That's kind of like part of the thinking you have to kind of do on these kind of problems. Think through it. What do these words mean? The measure of angle PQS, this guy right here, this measure, is 5 times the variable y. Okay, so 5 times y minus 1. So this here is 5y minus 1. And the measure of angle PQR, this whole thing is equal to 8 times y plus 12. So 8y plus 12. 8y plus 12. All right. And they want us to find the measure of angle PQS. PQS. They want us to find, what is this one? What's that one? To do that, we're going to have to set up an equation. So pause it and see if you can set the equation up. 30 seconds to set this equation up. If this is hard, this is like the hard. I think this might be the harder part, setting the equation up versus the algebra. But let's try to give it a shot. Pause 30 seconds. Try to set an equation up. Okay, you tried setting an equation up. So here we go. Well, we know. Remember, part plus part equals whole. Part plus part equals whole. So we know that the whole is 8y. I'm sorry, 8y plus 12. 8y plus 12, right? There's my 8y plus 12. And I know that's got to equal this part here, 5y minus 1. 5y minus 1 plus this angle over here. But I don't know this angle over here. Hopefully you realize, well, if this bisects the big angle, that means it cuts it in half. And what we know about cutting things in half, it creates 2 equal halves. Both halves are equal, right? If it cuts this in half, then if this is 5y minus 1, well, then that guy's 5y minus 1. So that means this is, I have to add part plus part. Part plus part equals whole. Part plus part equals whole. So this part plus this part equals the whole part. And I know these two are the same. So I can put this in 2. I could have multiplied by 2 here too. It's up to you how you want to do that, but okay. Step 1, actually maybe pause for a minute to see if you can solve it from here. Can you combine the like terms and do the algebra? Give it a shot. Okay, you unpause the video because you're ready to kind of see it in action. All right, well, I can combine some like terms here. I've got these 2 negative 1s that I'm going to combine into negative 2 because negative 1 plus negative 1 is negative 2. So here I got negative 2. And I can combine the 5 y's together because it's 5 times a number I don't know plus 5 times a number I don't know. I can add those together and get 10 times a number I don't know. All right. If anybody wants to try to solve it on their own from here, you can pause or you can keep watching. Maybe that was the hard part, combining like terms. But I'm going to strategize for a second here. My strategy is I want to move the 8y over to the 10y because that will give me a positive 2y. So I kind of see that ahead of time. If you don't see these kind of strategies ahead of time, that's okay. You'll kind of learn as you go. But think about why am I gotta do one thing or the other, right? I gotta either subtract 8y from both sides or 10y from both sides. And this way I'm left with a positive 2y. And that's what I prefer. I'd rather deal with positives if I can help it. So this 8y, positive 8y plus negative 8y, this cancels. This goes away. I can now ignore this. And then 10y minus 8y is positive 2y, as I said. All right. And now, because I want to get this thing by itself, me pick a good color there. There we go. Maybe that one. I want to plus 2. I'm going to plus 2 over here. Why? Because plus 2, positive 2, cancels on negative 2. I'm adding 2 over here. Again, equations are balance beam. If you do something to one side, you got to do it to the other. Now this cancels. This goes away because negative 2 plus 2 is 0, which means I can ignore it, which means I got to deal with 12 plus 2, which is 14. And we have one final step. We have 14 equals 2 times y. I am not going to finish this for you. I want you to find out what y is. Y is going to be something. And then once you find out y, you need to plug that number in for 5 times y minus 1. So you find that number and do 5 times that number minus 1. Boop, that's your answer right here. Okay? I'll leave you to your calculators. Pause if you need to. I'm getting rid of this right now. All right, here we go. What is a right angle? Well, a right angle is a 90-degree angle. Or you could say perpendicular. Right? Okay. I'm going to leave you to this one to think about on your own. This is kind of a thinking question. You can just kind of puzzle it out in your head. Explain why any two right angles are congruent to each other, okay? Explain why any two right angles are congruent to each other. If every right angle is 90 degrees, then why are all right angles congruent to each other? I'll leave it to you. Here's a metronome. This is a picture of a metronome. Maybe you've seen one of these before. They're used in music, usually in classical music more often. But it's like this little thing where it's got this, oh gosh, I wonder what they call this. Is it a pendulum? It ticks back and forth. It goes tick, tock, right there's the little weight. And the closer the weight is, the faster it goes. And the farther up the weight is, the slower it goes. So it swings back and forth, tick, tock, and it swings forth at equal angles, right? So I want you to name all the angles in this diagram. So if you were naming the angles in this diagram, maybe pause, give this a shot on your own, do a little independent. Can we name angles in a diagram? Pause it, we'll find out. Okay. All right. There's at least 3 angles here, all right? At least 3 angles here, 3 obvious ones. There's angle AOB, right? AOB. There is angle BOC, angle BOC. And there's one more angle in here. It's the big one, AOC, right? Angle AOC. And if you are doing this on paper, feel free to use that angle symbol that looks like this, so you don't have to write the word angle out every time. Okay? All right, here is a protractor. Here's some protractor questions. I'm going to do the first 2, and you can do the rest, all right? So here's a protractor. It's an angle measuring tool, and I want you to measure the angles and classify. So angle VXY, there's V, there's X, and there's no Y. All right, do VXU. All right, sorry about that. I must have goofed this up. Do VXU instead. VXU. All right, so to do VXU, we're going to have to try to figure out what's the difference between this measurement here and that measurement here. So if I'm reading this, I'm seeing that this one's at 110, and then this one's at if I'm reading the top one, I got to stay consistent. So if I'm going to read this one, I'm at 110 right here, 120, 130, 140, 150, 160, 165. So break out your calculator here. Oops. I'm going to break out my calculator here and say, what is, sorry, I'm going to try to put that on your screen somewhere so that you can see the calculator. All right, Mr. Calculator, tell me what 165 minus 110 is. 165, what's the difference between 165 and 110? Minus 110. And, it's 55. So this angle measure is 55 degrees, the difference between this measurement and that measurement there. Fair enough? All right, I'll do this one, and I'm going to have you do the rest. Find the angle, and 55 degrees is less than 90, so it's an acute angle, right? So it's 55 degrees acute. Use a protractor to find and measure of the angle. Find the angle of TXW. TXW. Okay, well this one's a little bit easier if you know how to read the protractor. So if you notice, this side, this upper area of the protractor starts kind of at 0 and goes 10, 20, 30, 40, 50, all the way to 90, and then goes into the hundreds all the way to 180. While the inside track of this protractor starts at 0, on the inside goes 10, 20, 30, 40, all the way to 90, and then on to 180. So you can kind of read this protractor one way or the other. So because this is TXW, I can actually read it on the inside track starting here at 0, which makes it kind of easy. So this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And it's between 100 and 110, which would be 105. So 105 degrees, and anything over 90, greater than 90, and less than 180 is an obtuse angle. All right, so 105 degrees and obtuse. Sorry about that. Go ahead and do the rest of these. Press pause and go crazy with them. I'm not going to go over them. I want you to do these independently. I think you can handle it. Oh, there's only one more left. Oops. Okay, I thought there was 2 more of those. Sorry. Well, all right. In terms of application, some of this degree stuff is used by land surveyors. Have you ever seen guys in yellow vests, hard hats on? They got this little tripod thing going on with like a camera or something, some kind of mechanical device, and then like maybe 100 yards away, there's somebody else with like a little pole sticking with a little flag on it. Those are land surveyors, right? What they're doing is they're taking careful measurements of angles in order to measure the land, in order to determine property boundaries, in order to measure where roads are going to go, to plan building sites, all sorts of stuff. If you like geometry, if you're into it, there may be a career in land surveying for you. And in the extension, on the extra credit stuff at the bottom of this, there is there is some videos on land surveying if you're interested. All right, so a surveyor, a land surveyor at point S over here, discovers that the angle between peaks A and B is 3 times as large as the angle between peaks B and C. So this here is going to be 3 times as large as this angle here. And don't be afraid to mark up your diagram, especially if you're using paper right here. So they don't tell me what this one is. They just tell me that this one is 3 times bigger. Well, again, what do we do in math when we have a question mark? When we don't know what this is, we just know this is 3 times bigger, right? We give it a variable. We'll say it's 3x. We like x in math. You could use any other letter you want. So we're just going to call this x then, right? That's like a little question mark. Right? X is a question mark. So, okay. So we know that this is 3 times as large as the angle between B and C. The surveyor knows that angle ASC is a right angle. And notice it's diagrammed here. This little corner, kind of like an arc mark, indicates that this is a right angle, which is 90 degrees. Find the measure of angle BSC. So we want to find this one right here. We do want to find what BSC is. So we're really just solving for x. So we got to use what we know about this. We know that this is a right angle, therefore we know the whole thing is 90. And part plus part equals whole, right? Part plus part equals whole. You know what? I'm going to let you go crazy with this algebra. You're on your own for this one. I think you got this. All right? Combine like terms, and then remember there's a 1 in front of here. Okay? All right. Once you find out whatever this value is, remember this is 3 times greater, so just multiply your answer by 3, and you'll have this one. All right? You know what? We're going to skip the trisecting angle. I want to do that one in person with you sometime. Okay? All right. So I wanted you to get this idea that a circle is 360 degrees. So I have this pie chart, this circle graph, or pie graph. All right? Types of CDs in store. So in some kind of store that must sell music CDs. Apparently 25% of the CDs are rock and roll. 30% of the CDs are R&B, 10% are rap, and 35% are jazz, okay? I'm asking you to find the measure of AOB. AOB. So one thing you have to remember is that a circle is 360 degrees. So you have to find out, well, what is 25%? 25% of 360 degrees. And when you hear of in math, I want you to think multiplication, okay? So 300, here's my 360 degrees. What is 25% of it? So I got to multiply. And what am I going to multiply? Well, a percentage is out of 100, right? Percent, per 100, because if you have 100%, you have everything. So what you have to, hopefully someone's keeping me honest, yelled out, Mr. Solt, you wrote the wrong number there. 25 over 100. So when you're converting percentages into decimals to be used for multiplication, you want to divide by 100 because a percentage is out of 100, right? This is 25 out of 100. So 360 times 25 over 100 will give you a number. That's your answer. I want you to pick up your calculator and figure that out. Make sure if you're using your calculator to put parentheses here. You will need parentheses there, all right? Actually, you won't need parentheses there possibly, but that's okay. It's always a good habit when doing fractions. All right, now find BOC, right? BOC is BOC, that's jazz. Okay, we're going to find the measure of BOC. And in order to do that, we need to find out what 35% is out of 100. Now, you could just put 35 over 100 in your calculator, and it'll say 0.35. So if you want to do this and put 35 over 100 every time in your calculator, you're certainly welcome to do that. But, if you can realize that, 25 divided by 100 is going to be 0.25, and that 35 divided by 100 is just 0.35, you could do these kind of just by moving a decimal place over, right? You could just move a decimal, boop, boop, 2, because there's 2 zeros in 100, and do these a little faster. But however you want to do it, go for it. I'm going to leave you to it. I have confidence in you. You can do this. Some more of these. Let's see. I will let you go crazy with those. Bisecting a segment, I think we're good there. We've talked about midpoints and bisectors. And previously, we did this construction in class, but actually bisecting a segment, if you haven't done that, see me. We need to make sure you've got these constructions down. They're worth half a day. So you're going to take your circle tool and do a little arc that's over half of the distance of the segment. You're going to keep that same exact circle measure, and you're going to do the same side at B. On the other side, your two arcs will intersect if they're greater than half the length. And where they intersect, do a straight line, and that is a perpendicular bisector, where it intersects will be the midpoint. And in application for baseball, so some of this geometry stuff is also used in baseball. Who knew? So apparently, in baseball, you have to throw a strike, and a strike zone is defined as the top is the horizontal plane passing through the midpoint between the top of the hitter's shoulders. So the strike zone is the midpoint between the top of the hitter's shoulders and the top of the uniform pants when the player is at batting stance. So this here is the midpoint between this and this. You have to find what the midpoint is for T. Yes, for T, the player on the left. And then I have another one. I want you to find also the strike zone T for this player on the right. Okay, as always, tricks for understanding will be on your own. Please complete these. I hope you have a good day. These tricks for understanding will go in as like a little assessment there, a little formative assessment. Please complete those. Tell me if you think you were successful, a little reflection on your learning. Here's some evidence for your learning. And let's see. Rate your own performance, okay? And I do, if you're on the computer, you have these videos for land surveying with some extra credit questions if you so choose. Not required, of course. Extensions aren't required. They're just pushing it a little further if you feel like you can do that. All right? So I'm going to get some rest, and I hope you have a great day.